All right, so we'll go back to our picture here. So what we want to think about is, how do we tell whether or not there is a horizontal winner? Well, we could probably do that pretty similarly to what we did for vertical, right? Kind of almost like just turn the turn the board on its side and write the same logic, okay? But diagonal then becomes a little bit more of a problem, because diagonal becomes more of a thing that's like relative to an individual checker. So let me change the rules up a little bit. Let's say that I was solving a problem, and this kind of gets back to what you were saying a little bit earlier. What if I was trying to solve the problem of asking, is this particular checker involved in a win? Okay? I want to know whether this particular checker is involved in a win. How would I do that? Not just horizontal or diagonal, or not just diagonal. I'm talking horizontal and vertical as well. So from the perspective of just this checker, is he involved in a win? So I want to know what's the streak? So his color, whatever color he is, how many up can I go and find the same color? How many down can I go and find the same color? That's my horizontal streak. Or I'm sorry, my vertical streak. How many left and right can I go and find the same color? That's my horizontal streak. How many up and up diagonal, down diagonal, and up the other direction, down out the other direction diagonal can I go? That's my streak in that direction. Does that make sense? So if I know a particular checker, row and column for a checker, let's say, I could ask, is this particular checker involved in a win? Correct? By counting 4 different things. The vertical streak, the horizontal streak, and both diagonals as individuals, right? And if I return true that yes, this guy is involved in a win for any of those, then we can return true. So I want to write a new version of his winner. Okay? Because this one's fine. The version of his winner we have right now is fine, and we can certainly add horizontal winners to this guy without too much trouble, using a pretty similar logic. But let's go ahead and let's write a version of this guy. So we're going to say is winner int row int column. So what we're interested in is relative to this specific checker. The checker at row, and call, is that guy involved in a win? Okay. Now, the first thing we can ask is let's go ahead and do this. We're going to say char cur color is equal to this dot the board at row call. Then we can say if cur color is equal to an underscore, then this guy's not involved in that win, right? If there's no checker there, right? So this is the checker I'm trying to see if this guy's involved in a win. If he's not a checker, if he is equal to an underscore, we can go ahead and just return false. He's not involved in a win, correct? Otherwise, we can start counting our streaks. Okay? So we're going to need 4 counters. So we're going to say int, let's call it vert streak. Start that guy off at 0. Int horizontal horizon streak. Then int diag1 streak. Int diag2 streak. Okay? So, 4 different possible streaks. So to get let's deal with our vertical streak first. To get our vertical streak, we need to go above us and below us. And actually, all of these streaks should start off at 1. We can go ahead and count ourselves, correct? Because if we're in this else, we're a checker. Okay, we're a checker that has color, cur color. Okay, so we want to. So for vertical, we want to go above us and find out how many things above can I go before I run into something that's either illegal or not the same color as me. Okay. So let's do that for above. We know we're in row, and column, column. So for vertical, column stays the same, correct? So we're just going to check the row. So we're going to check rows above us. So we're going to say while row, let's actually do it this way. We're going to say int cur row is equal to row. We'll start it off at, let's do row minus 1. So this is the ones above us. Rows minus 1 is the guys above us and up. Okay? So we'll say while cur row is greater or equal to 0 and this dot the board at bucket cur row col is equal to cur color. Well, both of those things are true. While I have not gone off the top of the board up here, and the next guy up, and the next guy up, and the next guy up are the same color as me, we'll say vert streak plus plus. Make sense? We break out of this loop when either we've run out of rows, we've gone off the top, or we found a non-matching color. Okay? So now let's go. So we can even put little comments in here. So we'll say vertical winner. So let's say check above and then check below. So let's go ahead and restart cur row equal to row plus 1. And we'll say while cur row is less than this dot the board at bucket 0. Well, actually, it's this dot the board dot length, like that. So while cur row is a legal row, and the same guy here. Now, one thing we do need to do here that we forgot to do before is we need to make sure we follow cur row towards the top. So we got to say cur row minus minus there. And then for this one, we'll say vert streak plus plus cur row plus plus. So this goes below us. All right, so that gets us our vertical winner. Now, before we even check for horizontal winners, we can go ahead and ask if we can say if vertical winner is greater than or equal to 4, return true. We have a winner. We don't care whether it was vertical, horizontal, or whatever. So if vert streak is greater than or equal to 4, return true. There was a winner associated with this checker. If we're still kicking, we're interested in horizontal winners. So let's check left. All right. So in horizontal winners, the row remains the same. It's the column that changes, right? So int cur col is equal to col minus 1, while cur col is greater than or equal to 0, and this dot the board at bucket row cur col is equal to cur color. So as I walk towards the left from cur col, if I'm looking at things that are the same color as the original checker, then we're going to say int cur col is equal to whatever the column that was passed in minus 1, because we're going everything to the left. So if the checker that we want to find out whether this guy is a winner, we already counted him, so we want to say col minus 1 to go here, and we're walking this direction. Does that make sense? Okay, so we're checking everything to his left. So in this case, the row stays the same. We're all in the same row, but it's the col that needs to change. So that's where cur col comes in. What did I call this guy? Horizon streak. So we'll say horizon streak plus plus. We'll say cur col minus minus as we walk to the left. Then we want to check right. So cur col is equal to col plus 1. So the guy right after it. While cur col is less than this dot the board at bucket 0 dot length. So while it's a legal position to the right, and this same guy then we'll say horizon streak plus plus, cur col plus plus to move that direction. All right, then we'll ask the question, if horizon streak is greater than or equal to 4, return true. We're still kicking. Let's go ahead and check our diagonals. Okay, now, before we do that, let's pause here for a moment. We're getting too far out of control. Let's just go ahead and let's just check our, make sure our vertical and our horizontal work for our game. Okay? So, if I'm still kicking here for right now, I'm just going to return false. There wasn't a winner with this checker involved.
And horizon, this is regardless of color, right? Color is just any color.
No, it is. It's when what we call is winner, we're passing it the checker we're interested in, the position of the checker. The very first thing we get is we get the color of that checker. So I'm looking for checkers around me that look like me. Make sense? Okay. So this is winner on a per checker basis. So I'm actually going to make this guy private. He's only going to be callable from within the C4 board class. And my is winner down here, this guy that we wrote with this red streak and black streak, all this stuff, okay, I'm going to go ahead and dump that. Because we're going to replace that by just going through and checking every single checker on the board. All right. So we have for int I, well here, for int row is equal to 0. Row is less than this dot the board dot length row plus plus. For int col is equal to 0. Col is less than this dot the board at bucket row dot length. call plus plus if this dot is winner row call return true. Otherwise, we'll return false if we've literally checked every single checker on the entire board and none of them return true. Then we'll just return false saying, look, I checked every checker. None of them are involved in a winning move. We'll return false. Okay? So now our code should work for vertical and horizontal winners. Make sense? Let's go back here and let's we'll go ahead and after this we'll go ahead and print out winner system. Like this. So as soon as we finally have a winner, we'll print out winner. All right, so let's run this. So let's make sure our vertical winner still works. So I'll bounce back and forth between, let's just do 1 and 2 because those will be easier for me to hit. So there's our winner. It didn't show the last move, but so it's detecting our vertical winner still. Now let's get a horizontal winner. So there's our horizontal winner. On my last move was the red on the fourth column. All right, so it's working for vertical and horizontal. All right, so now I need to write the code for diagonal. So far so good. Now this check thing is becoming a little bit verbose, but nothing in here is overly complex, right? We're just counting. We're just kind of spreading it out across the stuff. All right. So now we're going to check for diagonal. Let's do upper left to lower right. Winner. Okay. So again, we already have the current checker. In order to check the guy up and over to go upper left. So let's go upper left first. We need to have a cur call and a cur row, right? So we're going to go upper left. We already have the variables for cur call and cur row. So we're going to say cur call is equal to call minus 1. Cur row is equal to row minus 1. The guy up and over is 1 column over, 1 column up. All right, but that actually that should be row plus 1, right? No, it's minus 1, just because of the way this works. So if I'm looking at this checker right here, I want to do column minus 1 because this is column 0, 1, 2, 3, 4. This is column 3, so it's minus 1. And this guy is currently row 0, 1, 2, 3. I want to go to column 2 or row 2. So row 2, column 3. So it's minus on both of those to go up. Because we're checking the stuff up this direction from him. Then we'll check the stuff down this direction from him to count the streak there. So we want to say while cur call is greater than or equal to 0 and cur row is greater than or equal to 0 and this dot the board at bucket cur row cur call is equal to cur color. So as long as the current column is legal and the current row is legal and the checker at that position is the same as me, Then we'll go ahead and, what did I call it, diag 1. Let's just do this for diag 1. Diag 1 streak plus plus. And then we want cur column to keep subtracting and cur row to keep subtracting to find the next diagonal. So cur col minus minus, cur row minus minus. Okay. Then we need to do lower right. Go ahead.
There should be lower right to upper left. First one.
You mean here?
Yeah.
No, I'm doing upper left to lower right. So I'm doing, for this guy, I'm doing, here's the upper left, here's the lower right.
So we are moving from lower right to upper left.
Well, I'm just counting all of them. I mean, this is the stuff, here's the upper left stuff, here's the lower right stuff. You add up the streaks, and that's it. I mean, it doesn't matter whether you think about going from here to here or here to here. It's still the same line, right? Because the other one's going to be lower left to upper right. Okay? So now for lower right, we reset cur column. So this will be col plus 1. Cur col is equal to col plus 1, and cur row will be equal to row plus 1. Then while cur col is less than this dot the board, since we know the all the rows are the same length, we could say the board at bucket 0 dot length. So the cur column is a legal column, and cur row is less than this dot the board dot length, and this dot the board at bucket cur row cur col is equal to cur color. If all that's true, if cur row and cur col are both legal, and we are dealing with the same color, then we'll go ahead and say diag 1 streak plus plus, cur col plus plus, cur row plus plus. All right, so that's, if I start here, I'm looking at this guy, that is col plus 1, row plus 1. Then col plus 1, row plus 1. Adding them all up. All right, so I'm counting how many streaks we had down this direction. Before that, I counted the number of streaks I had in this direction. That is col minus 1, row minus 1. Col minus 1, row minus 1. Okay, to go up there. So now we ask the question, if diag 1 streak is greater than or equal to 4, return true.
In that case, don't we have to check both the columns and the rows are within length?
We are, right here. So at the very beginning of our while loops here, we're saying for the upper left, we're saying we want to make sure cur col is greater than or equal to 0. So we're not going too far this way. And we want to make sure that cur row is greater than or equal to the length. Or rather less than the length. So that's this one right here. Cur col is greater than or equal to 0. And cur row, we said greater than or equal. Oh, it is. It would be greater than or equal to 0 because this is bucket 0, bucket 1. So as long as col doesn't go too far this way, and as long as row doesn't go too far this way. So we make sure it's legal before we check the color. And similarly, when we're going to the bottom, we're making sure cur col doesn't go too large, which means it's not greater than, we make sure it's still less than this particular row's length, because the last legal bucket would be the length minus 1. We also make sure that the row isn't is still less than the number of rows length. So cur col is less than this particular row's length, and cur row is less than this particular column's length, which is the number of rows on the board. So those two things, since these are all ands, we will never check this right-hand part. We won't even try to access the checker at bucket cur row, cur column, unless we already know cur row and cur column are legal. Because Java is smart enough to know how ands work. And in order for an and to be true, all parts must be true. So if we hit a false right here, Java's not going to waste its time checking the other crap. Right? Because a false and whatever else is going to be a false. So let's not waste our time checking stuff that doesn't matter. Which is good because we potentially might be giving it bad values for cur row and cur column if they didn't check out over here. Make sense? All right, so that's for that diagonal streak. So now we need to do the other diagonal streak. That is the stuff lower left and upper right. All right, so to get, so let's do lower left first. So we're going to say cur col is equal to col minus 1. Go left 1. But cur row is going to be equal to row plus 1. This is the checker. We want to go one column this way and one row this way. This is a plus on the row, but a minus on the column. Okay? Cur row is equal to row plus 1. Then we'll ask the question, while cur col is greater than or equal to 0, so as long as cur col is a legal column as we're moving here to the left, and cur row is less than this dot the board dot length. Because that guy's going down. We want to make sure it's less than, we haven't walked off the bottom of the board. Okay? And this dot, the board, at bucket, cur row, cur col, is equal to cur color. Then we'll say diag2 streak plus plus. And we'll say cur col minus minus and cur row plus plus. All right, then we're going to do upper right. So we'll start cur col off at col plus 1. We'll start cur row equal to row minus 1. While cur col is less than this dot the board at bucket 0 dot length. So while cur col is a legal column, as we're moving here to the right, because we're doing upper right here. So cur col is going to go this way, cur row is going to go this way. Okay, so as long as cur col is less than the length of our this particular row, and cur row is greater than or equal to 0, because cur row is moving up this direction. So if both of those things are true, and this dot the board at cur row, cur col is equal to cur color, then diag2 streak plus plus cur col plus plus per row minus minus. And then we'll ask if diag2 streak is greater than or equal to 4. Return true. Otherwise, no winners found, so we'll return false. Now look at that guy. That's from 18 to 120 to 126. That's over 100 lines for that one method. We didn't do anything hard in there, right? We just had to keep our numbers straight. All right, so let's test that guy. So now we should have this guy work for horizontal winners. It's always hard to win when you're trying to win. So let's do bucket 0, then 1, 1. Okay. Then we're going to go 2, 2, 3, 2. Okay. Then we're going to do 3, 3, 4, 0, 1, 2, 3. Oh, I accidentally won horizontally. I won down here. See, truth in advertising. I told you it's hard to win when you're trying to win. Let's try that again. It was going so well too. Okay, so 0, 1, 1. Now I'm gonna do 1 again. Then I'll do 2, 2, 0, 2. Oh. What? All right, we're still okay. We got a potential winner here on. Hold on. What was the last move I just made? All right, here we can do this. 0, that's an R. Okay. Then we're gonna do 0 again. All right. So now I need to do 0. Then I need to do 0, 1, 2, 3. There. That's our winner. So we just had a diagonal winner this way. All right, so that's upper left to lower right. So now we need to get a lower left to upper right to say we fully tested this, I guess. 0, 1, 1. Okay. Then we'll do 0, 2, 2, 2. Then let's do 1, 3, 3, 3, 0, 3. All right. Seems like it's working. I mean, we probably want to do a little bit more exhaustive testing, but seems to cover our bases. All right, so that should be full Connect 4 with super awesome epic is winner check on a per checker basis. Go ahead.
If the board is full and we are drops, the code has to look for like 42 certain.
Yeah. Technically, right now you could have a draw. So if you want to handle draws, we can ask if we could just count the number of underscores. And if the number of underscores is 0,
else we could just count the number of moves.
well, the problem, you could do that. You can count the number of moves. And as soon as you've run out of moves, because you could calculate the number of moves based on the rows and columns. So we could do that. So we can say in Connect 4.
Actually, that's not my question. If we are full and there's no way to check like 42 horizontal, vertical, and diagonal types, right? What if we could just keep track of our last move and just go 4 blocks before or 4 blocks after, 4 blocks up, 4 blocks down? That would be like much lesser processing time.
Oh, sure. But I mean, who cares? I mean, our processing time right now it's such a simple problem to solve. But you're right. I mean, so here, I'll just put that number in there real quick. So we can do that. We can find out. I mean, if you really wanted to go down that path, when we try to make a move in Connect 4, so we tell the board to make a move, this guy currently returns true, right? Well, we're asking if there's a winner, we could pass this guy the column that the winner was currently in. So we're only checking that, at least that column. So I mean, that's fine. I'm not sure this isn't like we're not trying to, shave off microseconds here because we're trying to, make something line up, in some sort of time thing with like the International Space Station or something. I mean, this is checking the board for Connect 4. So there are optimizations we could certainly make, but I think we're already checking the board substantially faster than you would in traditional Connect 4. Sitting there and trying to see, well, does somebody win? That kind of stuff. All right, so for the tie, we'll do num moves, and then we can go ahead and the board knows about num moves. Oh, I'm in the wrong board. That's my tic-tac-toe board. This is my board. So maximum number of moves is equal to the rows times the columns. All right, and every single time we do make a move, so we can ask the question here, private Boolean is tie. And in here, we can go ahead and take in an int num moves, and we'll return num moves equal to this dot max move. So if the number of moves that have been made is equal to the max moves, then this is a tie. This will boil down to true. Otherwise, it'll boil down to false. So now we have a way of asking whether or not we can ask the board, is there a tie? Because as it stands right now, what's going to end up happening is, the program doesn't crash or anything. It's impossible to make a legal move at the end. It doesn't matter which column you try to drop the checker in, you're out of moves. So it's just going to be the last guy's turn over and over and over and over again. Does that make sense? So one thing we could do then is inside of our play, where we ask, was the move legal? Then we do that. Inside the else, if the move was illegal, we can say if this dot, the board dot, oh, I made it private. I need to make this guy public. And then we also need to actually keep track of our num moves that start off at 0. So when a move was successfully made, num moves increases. If a move was not successful, it was either not successful because the stupid player made a bad move, right? They tried to balance the checker on top of a column that was already full, or we can ask if this dot the board dot is tie this dot num moves. And if that returns true, then we can say system.out.println tie game. Something like that. Now, if we go ahead and we break out of the program, break out of this loop though, what this is going to do is it's going to have us print out winner. Well, we've printed out tie game. So I'm actually, even though this guy returns void, I can say return. The return statement makes a method immediately end. This is allowed. You're allowed to have a return statement in a method that returns nothing. Just you can't have a return statement that has something after it. You can't say return 5. Because I've advertised I'm not going to return anything. But I am allowed to artificially kill the method. So by doing this, if I've noticed that, hey, this last move you made was illegal because the board is actually tied. We're out of spaces. It's a tie game.
So there is no exit in Java?
There is. But what if you don't want to exit? What if this goes back to that whole coupling thing? I mean, I can say exit, but then the entire program ends. What if whoever called play wants to play again and start the board over again? Okay, so rather than me making the decision here that, oh, you want the program to completely end, all I'll do is I'll say the play method's done. That's all I have control over. So I'll say returning no value because this guy's void, and that will make the method immediately end, which means I won't get down to this line. That line won't happen. All right. And I might. Before you, just 1 second. An interesting thing that sometimes this will happen to you, just as a heads up. Notice here that it says is tie. It's saying this guy's not visible, but I went and made it public, right? You see it's public now, but because I didn't save this file yet, it won't detect it over here. So sometimes it shows you have a bug, you actually don't. So I'll just save this file, and now you see it. The error disappeared over here. All right, go ahead.
I can't remember how I was going to phrase this, but before it gets down to the print winner, I checks numbers, checks for the tie. Would it actually go through? Like, would it actually go through the if statement for the tie if the first is false?
See, you're actually right. This is a bug. Because as it stands right now, well, actually, no, I think we're okay. Because we're only checking to see if it's a tie after we noticed an illegal move. We're only inside this else if the last move that the player tried to make was not allowed. Now, it could mean that move was not allowed because they tried to make a stupid move. But it could also mean that it was not allowed because, because we're literally out of spaces. But now, okay, we still do have a bug, though, because it's going to be kind of awkward at the end of the game. Where, if we think about this in real life, the board's full. We got 2 people sitting there looking at us, look, the board's full. Well, it hasn't told us the game's over yet. So then somebody has to go and make an illegal move. They have to, okay, there's the one checker. Whoop, fell off. Then this guy will detect that it was an illegal move. And at that point, it'll say, well, is there actually a tie? Then we'll notice that there was a tie. So, yeah, I mean, the way to do this...
It's almost like I gotta check it for every single move.
Well, okay, this logic will work for it. I was not necessarily sure if it's the best logic we can have for it. We can take this else out. And not assume it's going to be from an illegal move, because you could have one last natural move that results in not having a winner as well as having a tie. So what we'll say here is, while there is not a winner and there is not a tie, while both of those things are true, if either one of them becomes false, that means when we exit this while loop, we can't just assume it's a winner, right? We have to ask, is the current board a winner, or is the current board actually a tie? Asking it if it's actually a tie is probably less expensive, because we know how verbose our winner thing is. So what we'd have to do down here is, when we're out of this while loop, we know there is either a winner or a tie.
Also, an illegal move, even though it's not a tie, but we are trying to put a checker in a column that is already full.
Yeah, but that's not outside of the while loop. That's in here. We just don't toggle back and forth. We already handled that. The game still is allowed to go. You just kind of point at the other person and laugh at them and say you weren't allowed to do that. Okay? So when we're out here, we know that there's either a winner or there's a tie. Therefore, we'll go ahead and ask the question, if this dot the board dot is tie this dot num moves. If that's true, if there was a tie, we'll print out tie game. Else we'll print out winner. That make sense? Okay. So I think that'll get the job done. It's going to be really, really tedious to, I guess, create a tie game without accidentally winning. I mean, and that has more to do with the fact that I've been playing professional level Connect 4 for years. So it's very difficult for me not to win. That's what I'm really getting at here. All right. So now, before we take our next break, I want to show you something. Because now we all agree that our projects are starting to get a little bit bigger, right? We got more files getting involved, and he's complaining about number of lines of code. It's like, oh, it was 150 lines of code. The world is over. How many lines of text fit on a single page? Like if somebody has you write a paper, isn't it 80 lines? Yeah, I think so.
Single space.
Single spaced? How many lines are in that? Because double spaced, nobody really, usually it's space and a half, right? Mm-hmm. So let's say it's 60 lines per page. So really that's a 2-page paper. You're complaining that a 2-page paper was too long? It's terrible. But I have good news for you. The next homework, for the one I'm going to get you ready for tonight, makes this one look like, I don't know, when you play one of those old video games, but you're in the invincibility mode where you cannot die. Okay, this program that we wrote today was so easy compared to the next one. And the next one is just, I'm afraid to write it next week. And it just makes me nervous even thinking about, like, oh my gosh, I have to solve this in front of the class live. Bad news bears. All right, but I'm going to introduce a tool to you. And there actually are plugins for Eclipse that allow you to utilize this tool, but I want you to understand how it works by default first. How many of you have heard of a site called GitHub before? Let me bring up the keynote here. Have you been uploading to GitHub? We've been uploading all our code to GitHub? Using which tool? Use the command line tool? Oh, it's because I introduced it in that video that week I got sick. That's where it came from. Oh, okay. Not everybody's submitting it via GitHub. All right, so let me go ahead then, and I'll submit this to GitHub just so you guys have access to the code.
Well, we're having a hard time getting used to pulling it through the Git repository.
Okay.
We just go in there and just paste our code and send it. Or add.
All right, so let me show you how so I'm going to go here and I'm going to create a new repository. And we're going to call this guy CSC535 Spring 2017. So we'll just kind of put all our code up here from my class. That'll be easier for me to deal with. Okay, so now what I'm going to do is I'm going to go ahead and say create repository. Now, when I do this, it gives me all these commands, and these are the Unix Git commands that you can do if you're not using a graphical GitHub client, which the one for Eclipse kind of sucks, but I like to use the one from the terminal anyways. If you're on a Mac, Git comes with the Mac, so you can just go out to the terminal and use it. If you're on a PC, it's not a big deal. You just have to go out and get the PC version of Git. Okay, you can go and download the PC version of Git, and then what it does is you double click on it, and it gives you a terminal. So at the end of the day, you'll type in the identical commands to what I'm going to do because it actually gives you a Unix terminal. So you type in things like ls and that kind of stuff. All right, so the only line I'm going to copy here, because it'll save me some typing, is this guy right here. All right, so I'm going to go ahead and I need to go and make my repository. Because the way Git works is you have a local repository that keeps track of all the changes you've ever made. And you commit stuff to your local repository, and then you can optionally, in this case we're using GitHub, to get our code out there on the internet where it's easier to share with people. So you can push a local repository to a remote repository. So this line right here lets our local repository know that we actually have a remote repository that we're going to call origin. That's like the variable name for it. And this is where he lives. All right. So I'm going to go out to my terminal here. And I need to find where I put my Java stuff. I think it's Dropbox. Okay, that is not, wait, actually it might be. Yep, there it is. Spring 2017. All right, so that's where that folder lives. Now, an interesting thing you can do. I'll show you a little trick. I'm pretty sure this works on a PC, definitely works on a Mac. Okay, ultimately, I want to get into this directory called source that has my Java files in it. This is where I ultimately want to live. So I'm going to go ahead, I'll just type in CD. So right now, if I type in ls, I don't see those files. So I'm going to type in CD here, and I'm going to push a space. I'm going to open up my Dropbox. This is where I happen to keep my folder. So open up your directory structure and find out where your folder is. So I'm going to go to where that folder is. Eclipse Workspace, CSC535, Spring 2017. And then here's the actual folder right here, right? I'm just going to drag that folder into the terminal, and it puts the full path to it. Press enter. When I do ls, I see all my Java files there. So I'm going to go ahead, I'm going to do git init. This will initially initialize your Git repository, so first time you've ever done it. So it initialized an empty Git repository. Then I'm going to do a git add dot. So this will add all of my Java files and any directories that are in here as well to my this repository. So if I do git status after that, we'll see there's a whole bunch of new files it's creating. So it's creating all these Java files inside of our Git repository. Then I'm going to do a git commit -m, and I'll call this guy initial commit. So this is the message. So usually when you commit a change, you might say added feature XYZ or something like that. All right, so now it created those guys. So now my local Git repository is actually done. I've added all the stuff to it. I've committed everything. So now I could roll back to old versions if I break my code locally. But now I'd like to push it up to GitHub. So the one thing, I just need to do this once. I need to let my local Git repository for this directory, and let me just show you something here real quick. Well, I'll do it here first. But I need to let this local guy know about my remote repository. You just have to do this once per repository. So I'll hit enter there. Nothing seemingly happens. But now an interesting thing here, if I type ls, all we see is our Java files. I'm going to type ls-a. This will show you all the files. And notice we have one called .git. That's a hidden directory. Any directory that has a period in front of it is hidden. So that's actually where the Git repository lives. I could do cd.git, and that's my Git repository that lives in there. Okay. Now, this is actually pretty important that you get used to this command line stuff. Yeah, we're doing it here for programming stuff, but why do you think this might be handy for a IT professional? Okay, so good that you're thinking about it through the window of a programmer. Now, realistically, I mean, all of you are taking this first programming class. I hope most of you take the second one as well, because I think you want to have that background. I know that some of you don't like it, okay? I promise you put the hard work in, you'll get through the class. I'm not a big fan of failing people as long as you put in the effort, okay? But you want both semesters. That's an important skill to have, more important today than ever before, really, okay? But having said that, many of you aren't liking the programming stuff, right? And maybe you're kind of like, well, I'm going to wait and see if I eventually catch on. But you're maybe thinking, you know what? I'm glad I took the class so now I could appreciate what programmers are doing, but I'm also pretty sure this isn't for me. Fair enough? There's probably several of you that feel that way, correct? This is just not the stuff you want to end up doing. So that means you're going to fall on the more traditional IT side of things, correct? What do you think the traditional IT person does? They're setting up servers, things like that, right? Working with hardware. Well, some of the hardware you might be working with are like routers and switches and things like that. Routers and switches are running the Linux operating system. Okay, and they're in the floorboards on the other side of the, in this case, other side of campus or something like that. But wherever you're working as an IT professional, these routers aren't just sitting there in front of you where you can have a nice point and click, double click on icons and stuff like that. No, you're remoted in to a router using a screen that looks like this. It looks like this thing. You're using Unix commands to talk to that router that's sitting underneath the floorboards all the way across the building. So having familiarity working with an operating system completely from the command line where you don't have icons, you don't have all this other stuff, is a really important skill set. So for us, yes, we're using it as it relates to programming, but this could just as easily be a tool that's doing system-wide backups or restoring a user account or deleting users or creating users, all sorts of stuff like that. Okay? This skill is something that you'll be using. And it's one of these skills that often gets missed, because, especially today, because so much of our stuff is graphical user interface. Right? You know, we're used to using computers where everything's sitting in front of us. Okay? In fact, you know, probably many of you, until you ran into a class that asked you to use it, had never actually used the DOS prompt on your computer. Never had a reason to, right? Well, you know, years ago, so most of you are young enough that your whole computing life, you've had icons, things you double click on, right? All right, well, so you get a little older, like, you know, so I haven't, right? When I was younger, they weren't even thinking about icons. They weren't even thinking about a mouse. Yeah, that wasn't a thing. Okay, we didn't even have color screens. They had an orange screen that used some sort of like argon gas or something like that. We had one of those, and the screens were really tiny. But the point is that this comes very natural for somebody like me who did this for years and years and years. In fact, it took time to get used to the icon stuff, double clicking and things like that. But for you almost have to go the other direction. Okay? The stuff that you're going to be using as a daily part of your professional lives as either a programmer or an IT professional is very much going to be dealing with you're not going to have the mouse stuff. You're going to be remoted into a router that's using Unix commands. This is a skill set you have to have. Make sense? So even if you avoid programming, you're probably going to run into this more as an IT professional than you would as a programmer. Okay, so in any case, I have my repository created locally. I've let him know on this one-time basis that, by the way, there's a remote repository I'm keeping track of up there at GitHub, and here's his name. Okay, and then the last thing is we do git push -u. So git is the name of the program. Push is what I want to do. I want to push the local guy up to the remote guy. -u, I think, is for upload. Origin is where I am uploading it to. Okay, I'm uploading it to the guy I named Origin up there. If you remember right before that, when I did remote add origin, that's a variable name I associated with this value. That's the name of my remote repository. All right, and the thing I'm pushing is my master repository. That's the default name for your local repository. So I'll do that. I'm already logged in on this machine, so it did its thing. It's now uploaded up there. So I come back in here and I hit refresh. It'll show my files up there. That makes sense? Now, there are Eclipse plugins for GitHub and things like that. I would strongly encourage you not to use them, if for no other reason than grappling with getting used to command line stuff. Because it's an important skill set, even if you never continue with programming specific things beyond these couple of classes. In fact, it's most important for an IT professional. I would say many programmers can get away with without ever having to do it, because there are graphical user things. All right, so I'll go ahead and I'll throw this up on Slack, so you guys have access to that repository, and we'll just keep updating that repository for a little bit as we keep adding stuff to it. But that should be our final connect for full-featured whatever, blah, blah, blah. All right. Any questions about that? All right, so let's take another 10 minutes. So come back at 37. Come back at 8:37, and we'll do the next stuff that'll prepare you for the next homework assignment.